Hi guys, welcome to another installment of Local Debate today. Today I'm going to take you guys through more of the fundamentals for the application clusters. Today I'm going to focus on parameters, on common errors that you encounter in the application in a RAC environment, and also I'm going to focus on voting disk. So basically, these are some of the parameters that I know I covered this time or last time, and then this is referring to the communication between the node and the voting disk, and then the miscount is the communication between the different nodes. So it's actually referring to the network heartbeat, and this one is the voting disk heartbeat. And then this is a new parameter, the reboot time. This is basically how much time the node has to reboot once after it has been evicted from a cluster. And then the last two parameters are again priority, just for Unix and 34 Windows, and then you have the log file size. And also another thing to mention is these are the default values: 200 sec, 30 sec, and also Oracle advises RAC users to not set these parameters lower than these values. So this is just that's their recommend. These are the recommended sort of like bottom line values. So basically, in terms of node communication, so actually this is a very good diagram. So here you have the different nodes. Again, this is a cluster synchronization service statement, the processes, and basically this is how they are communicating with the voting disk. Again, this is also referred to as a voting file. And the thing is, each of these nodes, they each have two blocks, as I mentioned before, two blocks, the kill block and the whole block in the voting disk. And also they have and also at any point in time they should be able to access at least half the voting disk. I'm going to cover that later on in another slide. And also so pretty much I just wanted to show you guys what's going on, the communication that you expect. And also here at the top you have something that's very important in terms of communication amongst nodes in a cluster. They use what's known as a private high-speed interconnect. So that means that basically that's technology that helps them sort of communicate, sort of like check to see if they're still available and if they can still sort of pass along this type of information amongst each other. And also this is just a clear diagram for the voting disk. So basically, in terms of voting disk, so this is a concept that actually that you have in green infrastructure, with green infrastructure, and especially in terms of maintaining a RAC environment, 2 node, 3 node, whatever number of nodes that you have. Again, so here what you have is you have a redundancy definition. This one's a node redundancy. So what you come across also is that voting disks are also referred to as quorums, voting quorums. So when you're setting up your ASM instance, it's going to ask you for a disk group. It's going to ask you for this name. It's going to ask you to obviously assign a disk group name. It's also going to ask you to create a voting a disk quorum, and a disk quorum is a voting disk. So just to make sure you guys, this is a heads up. Basically, when you're setting up your ASM instance, when you see quorum, it's actually referring to the voting disk. And also, again, this is just the diagram. You have this. Basically, you have all the different disks, and combined, they are part of the shared storage that all the different instances are using for in a RAC environment. And also and these are just some notable things some facts about a voting disk. Basically, it's used by the CSS cluster synchronization service that I showed you guys a little bit earlier. The CSSD again. These two names are interchangeable. You can just say just or CSS. Basically, what a voting disk does is it requires the managing information of nodes in a cluster. As I've told you guys already. Basically, that's where the nodes. That's sort of like a so the nodes they have communication among each other, but they also do stop in this. They do like make like have communication with the voting disk, and that's where a lot of the communication takes place. So the voting disk has information on the nodes and their availability, and also and then also each node must be able to access at least half space in the voting disk. So that's something I mentioned to you guys already. The node basically what it does is it basically goes into a voting disk and going to voting disk, leave some some traces, and so the voting disk knows that pretty much this node is still available. And basically that's just how the voting disk heartbeat being maintained between the node and the voting disk. And also it's recommended that you have 2 voting disks plus 1. Again, voting disk or voting disk file, they're the same thing. Again, it's just I'm not too sure why Oracle recommends it, but they would rather just have you have an odd number of voting disks for your configuration. And the last thing is each node has at least 2 blocks in the voting disk. I've already mentioned this to you guys. So basically, you have the kill block and you have the whole block. The whole block basically is what again the node is going to leave some traces of its of data in there, and then the clear block is sort of like it's sort of a self-eviction mechanism, right? So if the node basically goes in there and tries to go into the kill block and finds that that space has been filled, that basically just tells that node that basically it's under the assumption that you are not available anymore, and that's why we're taking up all the space. And the reason the other nodes, the data from the other nodes is the reason why that kill block is actually no longer available, because when let's say you have a 3-node environment. So basically, if you have one of the nodes that's going through some irregularities, so the 2 nodes that are still functioning that are still functioning in the right way. So what they're going to do is they're going to go into the voting disk. They're actually going to sort of like again they're going to be going back and forth between these two blocks. So that means that basically they essentially that's the usual process of doing things. But what they will also do is they will go into the voting disk, and then they will fill up blocks that they assume that they will fill up blocks when they assume that under the assumption that the other node, the third node that they were communicating with, since it's no longer responding, that block node is no longer available. So when that last node tries to come into the voting block to access its own kill block and whole block, it's gonna look at the kill block and see that my block has been taken over. So that means that basically I'm not being accounted for anymore. So it's gonna self-evict from the cluster. And also again, this is a very common error. This is a split point syndrome. So basically, it's just think of it. This is an example of what I just explained to you guys. Well, basically, if you have a 3-node environment, when the 2 node realize that the third node is no longer communicating, what they're going to do is they're actually going to try to see if they can evict that node. So it's either two things going to happen. Either they're gonna evict that node, or the node is gonna evict itself. But the thing is, they will not allow for that one node to just sit there and to not do anything. That's the way Oracle configured it. If you have a 3-node environment, the three nodes are expected to be to communicate. And also, let me just make sure. Exactly, and also this is a very important point. So if you leave your the reason why the node has to be evicted, basically this is the way to explain it. The problem is if you can use instances running, certain block might get read, updated, these new instances, there will be data integrity issues. So basically you're evicting the last node because of fear that that because it's running it can still be accessed. And if you set yourself up to have a container environment and you lose one of your nodes and it's still running but it's not communicating, then what's the point of having a container environment? You need to just get rid of that environment and then see if you can reintegrate it later on. And also another thing that's really important is that in terms of how the nodes go about evicting each other. The node that finds the inactive node first is actually the one that's gonna perform the eviction. So if node 1 was the first one to realize that realize that node 3 is no longer active, then that's gonna be the one to get rid of that node. And this is just a diagram of the split brain syndrome. If you look at the network heartbeat failure. So basically, this is a two node environment. So what happens here is that basically you have a failure here. RAC 2 is down, RAC 1 is down, and then basically, let's follow this way. Basically, if you look at this, the RAC 2 is therefore evicted. So again, going back to what I was saying earlier, basically you have the reason why the Oracle is able to figure out that a node is not functioning anymore is you can have multiple reasons. You can have basically the node as it goes into the void disk tries to write. Realize that its space has been taken up, so basically he doesn't have any choice but to self-evict itself. So this pretty much sums up the split brain syndrome. The nodes, once again, this is important. The nodes, they will do anything to just continue to communicate. If it's a 3-node environment and they realize that one node is down, they're gonna get rid of that node and then continue on with communication, and then it will just be a 2-node environment. And then also these are just reasons for basically no reboot. Basically you can have network failure. Again, what a no reboot is like what I just explained to you. Where one node fails, and basically it's not part of the RAC configuration anymore. So you have a network failure. Again, this is referring to what I just showed you guys, which is the heartbeat, network heartbeat. Now the nodes cannot communicate. You have also slowing interconnect. This is the connection method that the nodes use to communicate with each other. So if you have a slow interconnect, basically what's going to happen is that that's going to cause the node to reboot. Again, the actual name for this interconnect is a private high-speed interconnect, and if you have anything other than high speed, again, this is slow. Basically that's the reason why the node will reboot. And also you have voting disk and when this I/O. Basically what this means is that, as I've already explained to you guys, the voting disk cannot be read or cannot be read, or cannot be written to. Again, blocks of space have been taken up, so the node has to self-evict. And then also again, another thing to consider is the CPU. Basically, let's say you're overworking your CPU, you have multiple configurations all around the system, and then basically what's going to happen is that the CPU cannot account for the heartbeats, the network heartbeat, so the voting disk heartbeat. And also you have, like things such as you have a human errors where just files are moved around, or changed. And this is very important. You have to actually, you know what, I should have mentioned this to you guys earlier on. So this is you have to this is it. You have to configure this. This is very important. The private interconnect configuration. Basically, based on that configuration, you're either gonna have a private high-speed interconnect, or you're gonna have in your interconnect connections or communications. And again, another issue might be your OCSSD process is inactive. OCSSD is part of the if you guys remember, the CSSD is actually the cluster service synchronization service. So this is just another process that's included in that registry. And then also you have a cluster, just general cluster word errors. Again, cluster word I'm referring to, of course, to the CLS, the cluster ready services. If there's an error with those with that registry, then again that would be a reason why the node would reboot. And also these are just some locations for the files, for your good files. If you go into the green home, go into the log directory, and then you go to your hostname, you're gonna find the process logs, the CSSD, like in like all the different processes that are part of basically of your RAC instructional RAC configuration. All those processes actually they have their own file, so you'll be able to know which process is causing all the it's basically causing all the trouble. It's causing trouble by looking at the log files. So if you want to just look generally at the system, what's going on, if you set up your green infrastructure and basically it's not booting up, and you can look into your again the same directory, but you're gonna look into the other host name, that log file, and in that log file you're gonna be able to find. It's gonna tell you what's the issue. And this is it. Thanks a lot for watching, and I hope to see you guys next time.